Welcome to qnawire.
We're going to calculate the percent in mass composition of each of the atoms corresponding to the following formulas. So in this case, in CO, we have that the total molecular weight is going to be equal to 20.01 grams per mole. So for carbon, what we're going to have is that carbon is going to represent 12 grams per mole out of the 28.01 grams per mole. To know what percent this represents, what we want to do is multiply this value by 100, and this is going to give us a percent of 42.88%. On the other hand, for oxygen, we're going to do the exact same thing. In this case, it is 16 grams per mole over 20. Well, it would be, in this case, 12.01 on the first one, just to be extra accurate. On the second one, 16 grams per mole out of the 28.01 grams per mole times 100. This is going to give us a 57.12%. So over here, 42.88. Down here, 57.12. In this case, since we need to plug in the values up to 3 significant digits, that means we are only allowed to have 3 numbers. This would be 42.9% and 57.1. Now we're going to do the same thing for SO3. In this case, SO3 is going to have a molar mass or a molecular weight equal to 80.07 grams per mole. The percent of the sulfur atom is going to be equal to the mass of sulfur, which is 32.07 grams per mole, divided by 80.07 grams per mole. This is going to give us a 40.05%. Well, 0.52%. In the case for oxygen, what we're going to have is that this is going to be 3 times, because we have 3 oxygen atoms, 16 grams per mole, divided by the total molecular weight, which is 80.07 grams per mole. And this is going to give us the value of 59.947%. If we round this up to 3 significant figures, this would be, well, actually it should be 40.05, because in this case it is quite close enough, and 59.95%. And now for the last one, we're going to do NaH2PO4. I'm going to erase the result for both of these guys because we're going to require the space. So for Na2H2PO4, we're going to have that the total molecular weight is going to be equal to 142.96 grams per mole. The percent of sodium is going to be equal to 2 times the atomic weight, the atomic mass for sodium, which is equal to 22.99 grams per mole, divided by the total molecular weight, 142.96 grams per mole, and all of this times 100. This is going to give us, for sodium, 32.16%. Now let's do it for hydrogen. This is going to be 2 times 1.0079 grams per mole, divided by the total molecular mass times 100. This is going to give us a value of 1.41% in the case of hydrogen. For phosphorus, we are going to have a single phosphorus, so we can go ahead and directly plug in here the atomic mass for phosphorus over the molecular weight, 0.86 grams per mole, times 100. And this is going to give us 21.66%. And finally, we're going to get the percent of oxygen, which is going to be 4 times 16 grams per mole, divided by the molecular weight times 100. And the result here is going to be equal to 44.77%. Rounding up the values to three significant figures, we would end up with 32.2, 1.4, 21.7, and finally 44.8. So that will be all. Thank you very much and have a good one. Notice here that if we round up according to the rules, you are not going to end up with the 100%, you end up with 100.1%. So the correct value should be the ones that we have over here. That does add up to the correct value. Remember that whenever we're rounding up in terms of percentages, we're not always going to get the 100%, so it is useful to take more decimal points.